The source of the cosmic ocean. Since time immemorial, humanity has gazed upward at the heavens in awe. The night sky, filled with shimmering stars and distant galaxies, evokes a vastness that feels both beautiful and mysterious. We often speak of the universe as a kind of ocean, deep, vast, and full of unseen currents. This metaphor, the cosmic ocean, captures both the poetic wonder and scientific reality of our universe. But where did this ocean come from? What lies beneath its surface? And how did the cosmos grow to be so large, so complex? In this video, we will explore the origin, the unfolding, and the destiny of the cosmic ocean. We'll trace its birth in the earliest instance of time, follow its expansion into the galaxies and stars we see today, and consider the invisible currents, dark matter and dark energy, that shape its every motion. Along the way, we'll explain key scientific ideas in clear, simple language so that any curious viewer can follow along. Outline. 1. The cosmic ocean, what it is and why we call it that too. The Big Bang, the birth of space, time, and matter. 3. Cosmic inflation, the rapid surge that shaped the whole universe. 4. Cooling and nucleosynthesis, building the atomic realm. 5. Recombination and the cosmic microwave background. 6. Structure formation, galaxies, clusters, in the cosmic web. 7. Quantum origins, the role of smallest scales in shaping the largest. 8. Dark matter and dark energy, the hidden depths. 9. Possibilities beyond our universe, the multiverse idea. 10. The future of the cosmic ocean, possible fates. 11. Our human role, tools, telescopes, and the quest to explore. 12. Conclusion, what the cosmic ocean teaches us about ourselves. Number 1. The cosmic ocean, a universe understood as a sea. The idea of the universe as an ocean comes from thinkers and scientists who saw in the night sky a vast sea of galaxies, drifting star systems, and drifting particles. Carl Sagan famously spoke of the cosmos as an ocean of space in which humanity sails a small ship called Earth. Viewed from Earth, stars and galaxies appear as boats on that ocean, distant, drifting, and illuminated by countless lights. Scientifically, the cosmic ocean comprises everything. All visible matter, such as stars, planets, dust, and gas. All invisible matter, like dark matter that exerts gravity but reveals no light. All dark energy, a mysterious force causing the universe's expansion to accelerate. The fabric of space and time, the very stage on which the cosmic drama unfolds. The laws of physics that govern everything from electrons to galaxies. That ocean is not static. It is dynamic. It flows, expands, and evolves. Number 2. The Big Bang, birth of this ocean. The dominant scientific model for the origin of the universe is the Big Bang theory. This term can be misleading. There was no explosion in space, but rather an expansion of space itself. Roughly over 13.8 billion years ago, the universe began from an extremely small, hot, and dense state, a kind of primeval singularity. At that instant, not only did matter and energy exist, but space and time themselves came into being. Then space began to stretch. As it stretched, the universe expanded and cooled. In that instant, the cosmic ocean was born, not as a body of water, but as a vast expanding volume of space containing first energy, then particles, then atoms and stars. That initial expansion, very rapid, marked the inflation of the first cosmic ocean. Number 3. Cosmic inflation, the instant surge. One of the most remarkable ideas in modern cosmology is cosmic inflation, proposed in the early 1980s. This idea suggests that just after the Big Bang, in an incredibly short flash of time, perhaps 10 to the negative 36th power to 10 to the negative 32nd power seconds, the universe expanded exponentially. Imagine a balloon not just inflating, but inflating faster and faster and faster in a fraction of a blink. This rapid inflation solves several major problems. It explains. To uniformity. Why the universe appears mostly the same in all directions? Flatness. Why space behaves as though it has zero curvature on large scales. Inhomogeneity, seeds. Inflation stretched tiny quantum fluctuations into slightly denser and less dense regions, seeds for future structure formation. So inflation smoothed and scoured the early universe into a nearly uniform sea while planting the first waves in that ocean. Cooling and structure, the ocean takes shape. After inflation, the universe continued to expand, but at a slower rate. As it expanded, it cooled. This cooling allowed energy to condense into particles. Formation of matter. In the first few minutes after the Big Bang, protons and neutrons formed. These would later combine into the nuclei of light elements like hydrogen and helium. This era is called Big Bang nucleosynthesis, but it took about 380,000 years before atoms could fully form. That's when electrons combined with nuclei to create neutral atoms. This event, called recombination, allowed light to travel freely through the universe for the first time. This ancient light still exists today. We call it the cosmic microwave background, CMB. It's the oldest light in the universe and one of the most important clues about the early cosmic ocean. The cosmic microwave background. Light from early days. The CMB is one of the greatest discoveries in cosmology. It is uniform to about 1 part in 100,000, but the tiny temperature differences map out the density fluctuations left over from inflation. Those fluctuations later became galaxies and large-scale structure. In essence, the CMB gives us a snapshot of the universe when it was only 380,000 years old. For scientists, it is like an image of the infant cosmic ocean, frozen waves and temperature as hints of future formation. Structure formation, galaxies, clusters, and the cosmic web. After recombination, gravity began to amplify small density fluctuations. Slightly denser regions pulled in matter from their surroundings. Over millions of years, these regions grew into the first stars and galaxies. Stars formed from collapsing hydrogen gas. Galaxies gathered billions of stars. Galaxy clusters gathered many galaxies. On the largest scales, galaxies and clusters arranged in a cosmic web, with filaments, voids, and sheets stretching over hundreds of millions of light years. This cosmic web is the modern shape of the cosmic ocean. Galaxies flow along filaments, accumulate in nodes, and drift in dark voids.